All right, we now come to the point in the time in the lesson where I tell you the thing that we've been skipping that you should do first before you ever begin. You should always factor this, because if you factor, there might be things that cancel out. That would be a removable discontinuity. So we should always factor first. So I can see that I can factor the top and the bottom because they're squares. So let's start with the top. The top, if you don't know, that is a difference of squares. So it's going to be x plus 3 and x minus 3. Difference of squares means you can take the square root of both the first and second terms, and they're separated by a minus. But if you don't know that, you could do X method. You just put a -9 on top, and you're missing a b. So you're missing a 0x. The 0 would go there. What are the factors of -9 that add to 0? 3 and -3. So that's where that comes from. As for the denominator, what are factors of -6 that add to -1? Factors of -6 that add up to -1. Well, they would be -3 and +2. So you have x minus 3 here, and then x plus 2. Why I say we should do this first is because the first thing we should find is not the not the vertical asymptote, but we should find holes first, also known as removable discontinuity from earlier in the year. That's where we'll have a hole in the graph. It's when a factor cancels. So those are going to occur when x minus 3 equals 0, or said another way, when x equals 3, we should have a hole. Now we go through the normal order we've been doing. So we'll go vertical asymptote, which is an infinite discontinuity. That's, you set the denominator equals 0. What's remaining of it anyways? So when x plus 2 equals 0. So we have one at x equals -2. Finally, and I don't know why I said finally, it's not the last thing, the horizontal asymptote. We follow the rules, and you can go back to the start or here if you want. We have 1 power of x, 1 power of x. This is eats dc, which is also eats dc here. The exponents are the same, so we divide the coefficients. So we'd have y equals, and I'm just going to go from here, 1 divided by 1. Okay, you can always start from there if it makes it easier. And then finally, I can finally say finally, intercepts. That's when the top equals 0. So what's left over is x plus 3 equals 0. So we should have one at x equals -3. Now, this picture does have one mistake, and I'll show it to you. First, let's start here. Intercepts. I do have one of those at -3, 0. The vertical asymptote is at -2. The horizontal asymptote is supposed to be at y equals 1. The problem is, if you see, they have them counting by 2s. They should have had it counted by 1s, and it would be fine. So let's just change that to a 2, and this to a 4, this to a 2, and this to a 4. And now the graph is correct. And then do we have a hole here at x equals 3? Yes, we do. And so it looks like we did it correctly. That's a removable discontinuity. This is an infinite discontinuity. Now you can try this one.